Okay, so this is an audio recording for the reading for case number 6, the first one of the case number 6, which is exhuming IT projects from their graves. And it's an analysis of 8 different failure cases and the risk factors that cause those potential failures. Anyways, so it looks at each of the project failures. Now, what exactly is an IT project failure? It is basically a scenario where whatever you were trying to achieve did not happen. Now, there is no one strict definition to define whether an IT project has actually failed. However, there is a definition according to this particular research paper, which says development of operations ceases or leaving supporters dissatisfied with the extent to which the system has served their interests. So if a particular project is unable to fulfill the requirements that it was supposed to fulfill, it is considered to be a failure. Now, there are 4 types of IT project failures, and correspondence failure refers to the mismatch. Now, one of the first one is the correspondence failure, which is a reference to the mismatch of the system's objectives and the needs of the user. So if a system's objective was to actually say improve the efficiency of a particular process and it's unable to do that for the users, then it's considered to be a failure. A process failure is another kind of a failure that occurs when the development of performance is unsatisfactory and results in a system that is basically absolutely unworkable. So whatever you've tried to do is not working, then that's a process failure. The third kind of a failure is referred to as an interaction failure, which is observed when a system is implemented but it attracts little or no usage from the user. So a non-usage scenario is referred to as an interaction failure. As a superset of the earlier 3, an expectation failure, which is like a larger category where all 3 of these categories fall into, it refers to the inability of the project to meet the specific stakeholder or stakeholder group's expectation. So that's also a possibility of failure. Now, according to another research paper, it distinguishes between IT project abandonment and failure. Abandonment obviously refers to the termination of a project before the development is ended, while failure means that the development has officially or formally ended, yet it's failed in any of these 3 or 4 forms that we just talked about. So, there's been a little bit of research which actually identifies several reasons why a particular project could have failed. So IT project failure has been evaluated across the industry, and it's been found that there are 6 possible IT project risk failure factors involved that may result into a failure. So a lack of effective project management or skills involvement. So if you don't have the right kind of people for a particular project, if you do not manage them properly, that could result in a potential failure. Lack of adequate user involvement. If you don't involve the users who will be using the system from the very beginning, from the very first step, then that could cause a failure. Lack of the top management's commitment to the project. That is quite as self-explanatory. If the top management simply is not involved enough in the development of the project or in the implementation of that project, then that will result in a failure. The lack of required knowledge and skills in the project personnel itself. So if they don't have the necessary technical skills or the knowledge to run that project, to use the system that's been developed or to even develop in the first place, that can obviously result in a failure. Poor or inadequate training of the users is another reason why it can fail, because if the people are not trained to use the system later on, once it's actually been implemented, then they will be potential non-use that can result into a failure. And lastly, the lack of cooperation from the users. So if the users just simply resist a particular system's implementation, that can result in a failure. Now, another area of research has focused not on the understanding of the risk factors, but the actual systematic nature of the failure itself, for what has resulted in those failures. So such research actually recognizes that IT project failure is not just a single thing that happens. There are several things that happen together with it which result into a failure. So there are basically 5 or 6 different failed IT projects that are covered here in detail, and we can go through each one of them one by one, but there is a nice little summary at the end of these 8 cases that actually define why each of these projects failed. Now you need to go obviously read them in detail, but it actually talks about 4 main categories of risk factors that we talked about earlier, and there is a table here that actually relates to each of these projects' failures. So there are, of course, people-related risk factors, there are process-related risk factors, there are technical risk factors, and there are extra project risk factors. So this table, which is actually labeled Table 1, which talks about these 4 categories of risk factors, I shall display them on the screen right now so as to be able to review them constantly. Let's go to page number 6, where it actually is detailed. Let me zoom it out so that it's visible all at the same time. Now these are the risk factors that we're talking about. So each of these 8 cases has had one or the other of these risk factors actually implemented. So I'm not going to go into the details of the cases. You're supposed to read them on your own, but I will tell you what each of them is. Each of them actually face the risk factors. Now, let's start with the first one, the inexperienced clients or vendors. That happened in case number 2, which is WRHA, with the Denver City, and it happened in the Denver City officials case, which was case number 5, and the Fox Mayor case, which is case 7, and the vendor systems options case 6, where none of either the clients in some cases, and in some cases the vendors themselves, the ones from whom the software was being bought or was being taken, had little to no experience in dealing with similar projects of similar sizes, which is why it failed. So in case 2, 5, 7, and 6, the issues were related to vendors or clients. So in case 6, it was because the vendor themselves had no idea of such a similar level of an information system or of a system, and that's why they were unable to do the project and it failed. While in cases 2, 5, and 7, it was because the clients themselves, the companies or the businesses that were getting those systems made, had no idea of such a system, and they did not involve the right kind of experienced people to be able to do it. Now, the second people-related risk that happens is the lack of stakeholders' involvement. Now, the stakeholders could be the users, the stakeholders could be the upper management, the stakeholders could be the shareholders themselves, it could be any of those people or all of them. So, support from users in the first case was very limited, which was the Mandata case, which is why it failed. The users of RISP in case 2 were not engaged during the development process, hence the system that was actually developed was without their input and did not fulfill their requirements. And in case number 3, which is the AMRES case, the top level partners, the management itself, and the various organizations that were working together to make that system, or to implement that system, was simply not interacting enough to get that system up and running, which is why it failed. Now let's look at people-related risk factor number 3, which is overly ambitious top managers. So sometimes another very huge risk factor is that the upper management has some very high hopes from a system that are overly ambitious, which is just not doable. So that happened in the RISP case 2, it happened in case 3, the confirm case, the baggage handling system case in case 5, and the Delta 3 case in case 7. All of these represented situations where the top management had some absolutely out of the world ideas of what the system will actually do. They were not realistic ideas. They believed that the system would be something that it was never meant to be, and it turned out to be obviously a disappointment, which is why the projects could be considered to be project failures. As we discussed earlier, one of the failures is when it does not fulfill your expectations. So their expectations were far too ambitious, and that did not happen. The fourth people-related risk factor that got the projects to be failed. Remember, I said earlier that risk factors are the reasons that a project fails. A project doesn't just fail by 1 or 2 reasons. There could be several reasons simultaneously that cause a project to fail. So the fourth people-related risk factor is users' unfamiliarity with the system. So users were unfamiliar in the case 6 is information system or LASCAD after it was actually rolled out, which means that the users were probably not involved in the beginning. They were not trained properly, and that is why this happened. So if the users are not involved in its development, if they're not trained properly, and they just thrown at a system and asked to manage a particular system that they had no idea about, then obviously they will resist, and the project will probably fail because they'll be non-use. Now let's look at some process related risk factors that caused various of these projects to fail. The first process-related risk factor that we want to talk about is unclear scope and requirements. So if your information system is not clear about what it's trying to achieve, what the requirements that it's trying to fulfill are, what the scope of it is, what is it going to do, what is not going to do, then obviously such a project will never last. So the project scope is very important. This was, however, not the case in case 2, which was the IRISP case. The functional requirements in confirm case 3 as well as in VCF case 8 were not documented, and there was no understanding between what the users were hoping it would become and what the developers were trying to make it as. So they were unclear. Users were hoping for something entirely different. The developers were working on a project that was different. It was the same project, but they just didn't see the same picture. So because the scope wasn't clear and the requirements of the user were not truly translated to those of the developers, hence it failed. And then there is unrealistic schedule. Sometimes hurrying up a project or expecting the designers or developers to create it far earlier than what is actually happening causes problems. So the initial schedules of the baggage handling project in case 5, the LASCAD case 6, and VCF case 8 were absolutely unrealistic in relation to the size of those projects, the kind of complexity of those projects, and the upper management were expecting them to be completed far earlier, which was obviously unrealistic and not possible, which is why that was a risk factor that led to its failure. Poor budgetary control is another process-related risk factor. WRHA did not have the right budgetary control, hence it went over budget. FBI's constant requests for funds were approved by Congress in case 8, which actually meant that the project was over budget and they spent more money than they should have. So bad. Sometimes having less money being approved for a particular project can be a disaster, which is in case 2, or having more money being spent in case 8 could also result in a disaster. So the process-related risk factor number 4 is lack of change control. So in the Taurus case 4, the baggage handling system case 5, and the VCF case 8, they were all subjected to various changes during the development phase. This is a terrible idea. Once you've defined what a scope of a project is going to be, you stick to it. Otherwise, what happens is referred to as scope creep. You constantly add new features while the old ones are already being worked on. Now, obviously, when an entire system is analyzed and designed, it is created as a whole functional system. Now, if you attach more things to it at later stages, it's going to be a hodgepodge of various incomplete and complete components, and there will be lack of integration and integrity in it. Imagine a building being constructed and adding new floors to it while you're doing the refurbing of the interior. So obviously it's going to be a disaster. So this is what happened in all 3 of these cases, which is case 4, 5 and 8, where more features were added during development phase, causing tremendous problems, budgetary issues as well as the eventual failures. So let's look at some technical risk factors. Now in the technical risk factors, when we are talking about those, we are going to refer to the high technical complexity of some of the cases. The case 3, case 5 and case 1 and case 4 are all very complex projects, and especially case 3 and case 5 were already technical complex projects to begin with. The baggage handling system was not a simple thing, neither was the confirmed project. The Mandata case 1 and Taurus case 4 became complex as the projects were progressing and new things were added. So the high technical complexity led to problems because the right kind of people weren't identified earlier on, and then procuring them and finding the kind of resources and people later on, the HR resources as well as the capital resources, was hard, eventually leading to a possible failure. The technical risk factor number 2, which is inappropriate approach to project development. Now, if you do not follow a proper project development process, then obviously there are going to be problems. The approaches used to crash the schedule in 2 projects were flawed, right? Because they were trying to hurry it up too much. That happened in Taurus case 4. The development started before the design was actually finalized, which is a terrible mistake, because if you don't have the designs actually ready, the development cannot happen. And if it does happen, there's going to be a lot of missing information in it, because the design is created after the thorough analysis taken from the users as well as the current system, and that design is going to be the blueprint based on which the programmers are going to work. So if you start the designing without actually finding the true requirements of the users and the true analysis of the current system or the requirements from the future system, then you're going to end up in a disaster. That's what happened also in VCF case 8, where there were 8 parallel development teams, creating a lot of coordination problems. So 8 teams working simultaneously on different parts of that project without proper coordination was a huge issue. In Delta 3, which is case 7, they started on the wrong note with the coupling of 2 critical subsystems, namely the ERP and the warehouse automation. They should have kept them either separate or brought along one system that would cater for both of them. So they were working on 2 systems that were connected very strongly with each other, and they did not realize that that would become a problem. In the main RISP project in case 2, instead of focusing on the main system, they started focusing on 2 interim systems or in-between systems, and that of course caused a lot of problems with the project development process, causing a disaster. In the technical risk factor number 3, which is incomplete software testing. So if a software system is created and it's not properly tested, the quality assurance is not done, it's not thoroughly stress tested, it's going to collapse in a real world situation. That's what happened in the last cat case 6, because it was an emergency backup system that was never tested. Now imagine that you're creating an emergency backup system which is designed to be a backup to another system, and you don't do a thorough testing of it. So it's obviously going to fail in a real world situation, or it's going to cause problems in a real world situation, and that's a huge issue. Then there are extra project risk factors. So risk factors other than these, such as external environmental changes, which are obviously beyond your control, maybe government changes, maybe industrial changes. So the changing national economic political circumstances led to a funding cut because there were budgetary issues that affected the Mandata case 1. A market recession that made the commercial attractiveness of the Taurus system in case 4 was also an issue for its eventual failure. Then there is tight coupling with other ongoing high-stakes projects. Now, if you've got 2 projects going on and they're interconnected in the sense that they have an effect on each other, then there's going to be problems. So, of course, these are not risk factors that you can control. But the baggage handling system in case 5 had an impact on the timely opening of the international airport. So, obviously, it was speed up too much, and that caused problems. even before the Delta 3 case 7 was fully developed, it became coupled with the Fox Mayer's contract with UHC. So two companies were making a contract, and that particular system of Delta 3 that was being developed under the case 7 example was an issue. So obviously, if other projects are involved, that can cause several problems as well. So these are some of the issues based on which it can happen. The article also shows a figure that actually was created after analysis of the literature to identify what usual failures lead to what kind of problems. So notice that it shows that personal risk factors or people risk factors of users in familiarity with the system usually impacts the implementation stage, and the tight coupling of other ongoing systems also impacts implementation stages. The rest you can notice are impacting the development as well as the initiation stages of the project's IT lifecycle. So these two factors are a factor that are impacting in the implementation stage. Remind you again, the phases that you go through when you're talking about information systems are the planning, the analysis, the design, the development and implementation, and the eventual maintenance that happens afterwards. So this particular model for identifying which factors impact which stage of the IT project lifecycle is quite important. So you should definitely look at this from the perspective that where the implementation is causing problems, or it can cause problems. So remember, the user's unfamiliarity with the system will become a problem during the implementation of the project itself, and obviously being connected with some other systems is going to cause problems, while the rest are already mentioned. So this is pretty much it for this particular case. I would highly recommend that you go through the details of each of these cases to better understand the risk factors that I've talked about. Thank you.